Thanks everybody for joining us today for Meet the Minds Behind the Monitoring. My name is Auburn Meadows and I'm the Community and Event Manager here at AssetWatch, and I'll be your host today. Before we get started, I wanted to share a few housekeeping notes with you. First, this webinar will be recorded and shared with you post-broadcast. Second, we'll be answering questions live throughout the presentation, so drop your questions in the comments box. If we run out of time to answer your questions live, an expert will reach out to you directly. Today is not about slides or a formal presentation. It's about giving you direct access to our experts. Our condition monitoring engineers, or CMEs, work every day with plant teams to catch issues early, guide next steps, and keep machines running reliably. This is your chance to ask them anything. We'll kick things off with a few quick questions to get the conversation started, and our team has prepped a few case studies to share with you today, but we want to make this as interactive as possible. So jump in the chat, drop your questions, and we'll keep the discussion flowing around what matters most to you. Let's meet today's experts. Could each of you touch on your certifications, how long you've been in reliability, and how long you've been at AssetWatch? Let's kick it over to Chris to start.
Yeah, hi everyone. My name is Chris Becker. As you can see here, I've been in reliability for about 12 years, and then prior to reliability, I worked at a Gould's distributor pump facility. But within reliability, I used to do a ton of route vibration data collection. Obviously, sending customers all the reports on that. Did a ton of laser shaft alignment, field balancing, years of thermography, certified Cat 2 in thermography, ISO Cat 3 in vibration, also certified in ultrasound RDI motion amplification. And I have been with AssetWatch 4 years as of August 2nd. So nice to meet everyone.
Yeah, hey everybody. My name's Eric Fastbinder. Been doing reliability for a little over 14 years at this point. Current certifications that I hold: ISO Category 3, Level 2 in thermography, Level 1 ultrasound, also MCRL certified, and MLA1 certified as well. Just like Chris, done extensive field work with laser shaft alignments, field balancing, rotating machinery, shop balancing, rotating machinery. Done a lot of wrench turning over the years as well, general plant maintenance. Been with AssetWatch for the last 4.5 years of those little over 14 years of the experience that I have. Appreciate everybody's time today.
And good afternoon, everyone. Thank you for sharing your time with us today. My name is Dustin Moore. I live in Bowling Green, Kentucky, and if you're not familiar with that, it's about 1 hour straight north of Nashville, Tennessee. I've been with AssetWatch for about 2.5 years now. I also am a condition monitoring engineer manager, currently certified as Category 3 in vibration analysis, Category 1 in machinery lubrication analysis. Have about 25 years in the maintenance and reliability space. Spent 12 years working for an electric motor repair company. And I spent 12 years working for one of the largest coal producers in the United States, where I ran a reliability program. Over my career, similar to Chris and Eric, done a lot of hands-on repair, mechanical work and millwright work, shaft alignments, balancing, electrical testing, and of course, vibration analysis. As stated, we appreciate your time today.
Hey everybody, Kyle Privet here. So lubrication program manager here at AssetWatch. Been with AssetWatch since January. Shortly after that, I took over the lubrication program there. Have 15 years of experience in the reliability side of things, closer to 18, 19 years of experience in maintenance overall. Came from a technician background, worked for Caterpillar for a little while, worked at various mines in Wyoming and in South Carolina. So it's where a lot of my experience comes from. Currently have the Certified Lubrication Specialist, Machine Lubrication Analyst 3, Thermography 1, NDT, UT1, and Failure Analysis Level 2. So looking forward to speaking with everybody today.
Thanks for sharing that with us. So I know you guys prepped a few case studies. Could you walk us through a recent case where a small vibration spike or oil analysis result prevented major downtime? I'll pop your examples on the screen.
Yeah, so this is one of my examples. This is a crusher drive in a coal mining operation. This is actually in their preparation plant. The asset we're discussing here is a McClanahan Super Triple Row Crusher. So it's got 3 independent electric motors driving each one of those 3 shafts. The primary motor is hooked to a gearbox. The 2 secondary motors are each belt driven, and there's a lot of different speeds and ratios involved there. So on this particular one, our algorithms detected some changes in both velocity and acceleration all across the machine. We were able to look at the dominating frequencies and vibration signatures and isolate it to one particular bearing. We pinpointed this issue in February of 2024 and allowed the site time to acquire a spare bearing and plan for the replacement, which occurred in April of 2024. The 2 months of advance notice really helped prevent a very costly failure. You can see that the customer, this is customer inputted data. They accumulated that to $250,000 save, and the root cause of the issue was a failed auto loop system. This actually reoccurred in September of 2004, another failure of that auto loop system, and once again we caught it. So this asset alone, I think, is a good example because it's been nearly $500,000 of savings on this one, just this one machine. So.
All right, so we have a few keyed up here for the oil side of things. So this first one, it's an injection molding facility, plastic injection molding facility. We were starting to see, we were getting their first round of samples in, and we had started seeing some acid issues in the oil across multiple of the injection molding presses. Luckily, talking with this customer early on, we had told them the value in getting their new oil sample as well. So day went by, we started getting more of their sample results back, and this is what we found with their new oil sample. We had 9.68 on our acid number. This is around 18 times higher than what we were expecting for this oil. This shows the value of that new oil sample. Had this customer not had that new oil sample, we would have been chasing things all over this plant whenever the issue came back to the oil they were supplied. So I can't stress this enough, how important it is not just to get your oil samples on your equipment, but also your new oil samples as well. We were able to get this headed off and not waste time and manpower on chasing something that wasn't there. They were able to go to their supplier as well. Their supplier looked at the data, looked at what we were saying, said, yeah, this is a problem. We're going to take care of you. They ended up replacing all of their bulk oil, as well as paying for the oil changes on the affected equipment. So this also helped reinforce the relationship that this customer and their supplier had. So they know they can trust their supplier if something goes wrong. So it was a great all-around success there. Yes, a product was contaminated whenever it got to site, but we were able to figure out where it came from rather quickly. On our next one here, this is a little different than your typical win. We're looking at this, and as we look at this sample, we can see this progression of a failure occurring. We can see our iron, we can see our chromium, we can see manganese. All of this is starting to go up. This gearbox is going into failure. There is no doubt about it. We can see our PQ index going through the roof, particle counts through the roof. But what we were able to do was identify this early on. We were able to talk to this customer and say, hey, we're starting to see some oil samples that are going in a really bad direction. And we were able to do this back last year, well before, roughly 10 months before the failure was going to happen. We were able to give them that heads up. They were able to get this planned for. Having that ability to plan for a down event versus it happening unexpectedly is huge. As a lot of us in this industry know, some of these gearboxes that we have in our facilities anymore, they can be 30, 40, 50 years old, sometimes even more. Gearboxes that haven't been in production, maybe the manufacturer no longer exists or was absorbed by somebody else. Being able to find somebody ahead of time to be able to repair these gearboxes, be able to rebuild these gearboxes is paramount to a quick turnaround time, minimizing downtime at the facilities. This is, one of those great things with oil analysis is being able to see that long-term picture, not just going at it reactively and touching on what's happening right now, but planning for that future, being able to get those things in the budget, get that downtime scheduled to minimize the effects across the facility. And then this one is just really awesome to look at. So another plastic place, another plastic manufacturer, they had quite a number of extrusion gearboxes. Whenever they first started with us, the particle counts were extremely high across the facility. I want to say they have around 30 extrusion gearboxes there. So on average, we were seeing a 232117 ISO code, pretty high there. With our calculations, what we were seeing is that we were losing a lot of time across the facility. The average time loss that we were expecting to see with each of these gearboxes was around 1,200 days. So almost 4 years of lost life out of each one of these gearboxes. Working with them on implementing better practices around filtration, recommending the correct filters to use, how long to filter their equipment with their filter carts. We were able to start to see that change. We were starting to bring those particle counts down. On the latest round of samples, we were able to move 14 of those gearboxes into a very good place, from a 4-year estimated life lost to now we have a potential 2-year gain on each one of those gearboxes. A delta of 6 years is dramatic in a lot of places. So this is also showing the importance of making sure you're filtering and filtering correctly with the right equipment to be able to see these things. So, love seeing success like this. Customers love seeing the success like this. I think anybody that is facing problems in their facility would love to see a 2-year life extension on their equipment.
That's awesome, Kyle. Thanks for sharing that. Next question I have is, what technology do you feel catches faults the fastest? Chris and Kyle, can you guys take this, and I'll pop a P to F curve up for you.
Sure, Kyle. I guess I'll go first.
Yeah.
So on this curve here, it shows vibration catching faults first, and in the vibration world, depending on the fault type of the let's just talk about a gearbox. If there's specific vibration patterns, or say, structural looseness or a misalignment issue, we're gonna detect that first. We monitor a ton of gearboxes, and I see a lot of, gear mesh issues, potential gear mesh issues in the vibration data. However, I think that oil analysis can detect a lot of the internal, the internal wear and stuff a lot faster than vibration. So I'll turn that over to Kyle to discuss how oil analysis can detect that sooner than vibration.
Absolutely. Like Chris was saying there, sometimes vibration will catch things sooner. Sometimes oil analysis will catch things sooner. It's no blanket statement to say one is going to catch something over the other one. Of course, there's some cases where that may be true. If we don't have a vibration sensor on something, of course, oil analysis is going to catch it. If it's something that's grease lubricated, of course, vibration is going to catch it, not oil analysis. But using those together, we could really have a strong path forward to be able to catch those things as early as possible. Vibration isn't going to catch an acid issue. It's not going to catch a water issue. It may start to catch some contamination issues, or gear teeth chipping or bearings starting to spall out. It'll definitely catch those. But there's other issues like contaminants that just will not be caught with vibration. So they work together hand in hand to really give you the best chance to get to know what's going on with your equipment. And on to this next one here.
Yeah, so this is a great example. This is a customer that I work with. So this is a pretty large gearbox. I believe this is a 3-shaft gearbox. But what I was calling out on this, we were not doing any oil analysis on this gearbox at the time. but I was calling out a pretty significant gear mesh issue in this. And, I'd asked them, are you guys doing any oil analysis? And they had sent me a report, but the report was very lacking. And so AssetWatch, actually, we went in and pulled an oil sample on this. And there's a lot of detail that goes into this, but with oil analysis, we were able to really figure out that we worked with the customer and their engineering team and figured out that this gearbox, they were actually using the wrong viscosity oil. And once they were able to change that viscosity of the oil to the proper viscosity from a 220 to a 320, all of those gear mesh frequencies, the side banding around the fundamental gear mesh frequencies pretty much disappeared. It was very, very intriguing, very interesting. Kyle, was there anything that you would like to add to that?
Yeah, so if we look back at this previous slide real quick, one of the things you'll notice too is that when talking with them, we found out that they're filtering with 25 micron filters, which, yes, that is doing something, but that's a really open filter for the ISO codes that we're targeting. So we do actually, we were recommending not only doing the pitch line velocity to be able to make sure that we are using the correct oil, but also changing the filters to something much tighter, like a 10 micron beta 1000 filter. So that way we're removing more and more of those particles, getting that oil cleaner and cleaner. So they were able to implement that. And as we look at our wear rate graph here, we're going in that really good direction. It might be a little small on your screen there, but as we see the viscosity, it took them a little while to get it changed. Now filtering, changing the oil, they were doing everything they could to try to, clean it up, and it was starting to work, but that oil was just too thin for the application. So we were still creating a lot of wear debris there. As soon as they switched over to the 320 oil, we started seeing remarkably cleaner oil. So a combination of using the right oil and the right filtration, we're able to really start cleaning up this gearbox and going in the right direction there. So once again, this is a combination of oil analysis and vibration working together to be able to come to a solution.
That's a great example. So for someone getting into, condition monitoring and is new to it, what does the first 30 days look like? Kyle, can you speak to that for oil analysis first?
Absolutely. So we're going to work with you, figure out an asset list. We're going to be looking at all of your oil lubricated assets across your facility, whether it be turbines, hydraulic systems, gearboxes, compressors. Generally speaking, most things that are oil lubricated, we can monitor. So we're going to work with you, figure out what is the most critical assets to start with, and figuring out whether those should be on a monthly sampling cycle or a quarterly sampling cycle. Some things it makes more sense to do one than the other. After that, we're going to be discussing whether it's going to be a customer-led sampling effort or one of our ART-led sampling efforts. Our asset reliability technicians, we will send on site to get those oil samples for you. They will also do the vibration installs and collect routes as well, if that's a direction that you're looking at going. So after they get on site, they pull the first round of samples. Those get shipped off to one of our partner labs. Then we get that data back. It comes into our platform, and then your dedicated analyst is going to look at all of those oil samples. We're going to be looking through them, picking out what's going on with it. If they look good, great. If there's something that's wrong, we're going to give you a prescriptive recommendation as to how to go about fixing that, whether it be checking or changing filters, whether it be looking for the source of water ingression, whether you need to do an in-depth inspection of a gearbox, any of these things, we're going to help you put your resources to the correct area. After we go through that data, we are going to also set up a data review with you. So that way we can go through those recommendations, go through your oil samples, answer any questions that you may have around your lubrication program. We're here as an extension of your team, so we want to be there to help you and answer any questions that you have.
Yeah, and I can start off on the vibration side of things. The first 30 days for the vibration side, it's very similar to the lubrication. The lubrication team works very closely with the vibration team, and once the sensors get installed and the sensors are collecting the data, the designated CME that's assigned to your facility works with or looks through all the data. I apologize. They look at each monitoring point. For example, if you have a motor driving a fan, we would have a sensor at each motor bearing and then each fan bearing, and then all that data comes in, and we do a deep, what we call as a deep dive into that data. So we're looking for any type of fault that can be present. For example, if we see misalignment or potential bearing defect, or even a lubrication issue, like if the bearing looks like it's either under lubricated or over lubricated, we'll write up like prescriptive maintenance recommendations and or watches to call out the issues that we see. And then after 5 to 7 days, we meet with the customer to go over those maintenance recommendations and then try to work to resolve those issues. And then after, that happens really within the first 30 days. And then post the 30 days, the AI and the machine learning is looking at all of this data and then learning things and calling things out for us. And then I think we're going to discuss more on that next.
Yeah, absolutely. Like when looking at how you guys use AI, can you touch a little bit on that? And I'll pop up a poll while you guys discuss.
Eric, you want to lead off with that, or you want me to?
Yeah, definitely. I'll go ahead and jump in there. So there's a couple different things that are employed here at AssetWatch when it comes to AI and machine learning. We do have a dedicated data science team that's on staff working for us. We're continually providing feedback to that team via communication loops that we have built into the software on our side of things. If we identify certain faults that are within data, gear mesh issues, bearing problems, misalignment, so on and so forth, whatever we're seeing in the data, we provide that in a feedback loop to our data science team saying, hey, this is what we're monitoring. This is the application process fault that we're seeing, and they continually ingest that information back into our algorithms so that they're continually improving on what they're detecting within the vibration data for us. Because at the end of the day, what we want to do is make our condition monitoring engineers more efficient, where they're looking at the data that they should be looking at versus ignoring the stuff that is low level vibration, not really seeing any changes in the data. So we work very closely with them on that, and we have meetings constantly with that team internally, where we're not just providing that data feedback, but then also talking about how can we improve the various algorithms that we're using to detect different types of trend issues, not just what the content of the data is saying, but how are we weighing data when we see this type of temperature change or this type of RMS increase. And that kind of be a good segue over to more what you were going to be talking about on this front, Dustin. So you want to go ahead and hop in there and talk about that.
You touched on a few things here, but I think I'll go a little bit more in depth in some. So we do use AI in a few different ways. The first of which would be our detection algorithms, which are used to identify anomalies with rapid increases in vibration and temperature. In addition, as Eric mentioned, we use AI fault matching algorithms to help classify emerging issues. These sophisticated sets of algorithms kind of classify the risk analysis for each one. It helps us prioritize what our CMEs are looking at first. Next, we leverage that AI-based algorithm to prioritize things and analyze those first. This intelligent ranking helps our CMEs be more efficient in their analysis. It helps with better detect machine faults earlier, and it makes them more efficiently, just as Eric said. Also, we are using AI to help provide metadata to our CMEs. So we started with the ability to pull data off nameplate photos that our field techs or asset reliability technicians are taking in the field. So this AI tool will pull that information even on the dirtiest, most scuffed up nameplates. That gives us useful information such as RPMs, horsepowers, things like that, bearing information and such to use in our analysis. And one thing I love about working at AssetWatch is we are constantly brainstorming and looking for ways to improve, and AI is no different. I mean, we're constantly, just as Eric said, with the data science team in conversations, trying to figure out how to make us more efficient, how to make us more accurate. So that's just constantly evolving as we go.
That's great. Thank you both. Can you touch a little bit on how your team typically integrates into facility-led root cause analysis, or RCAs?
Anybody want to take that one?
So I think it just kind of it depends on how involved you want us to be or not. We're gonna whatever piece of the puzzle you want us to be, so to speak. We'll try to match that need. Some facilities. It just depends on where you're at in your reliability journey, for one, because some facilities do have a really good root cause failure analysis plan in place. Got a full FMEA built out for the facility. Some people don't do those root cause analysis. They don't have FMEA. And in those cases, we kind of try to help prod along, hey, this occurred, this happened. Maybe it was something that the data was kind of leaning us towards. Maybe it was something that came out of left field all of a sudden. We all know that sometimes bearings just break just because various things happen. We had a case recently with a compressor motor that actually was getting 3 different types of lubricant in it. It didn't really show anything in the vibration data, and then all of a sudden it really did, and it really went sideways very quick. So we'll again kind of prod and coach along where we see the need to make sure that we've got the best maintenance practices in place at the facility. For those that are more well-rounded with their programs and do proper FMEAs, they have those in place that do proper root cause failure analysis. We'll provide whatever data and communicate with you on what we are seeing on our side of things to help fully fill out those pieces of the puzzle that may be missing.
Yeah, I can add to that. Just a recent study or recent instance here. Customer of ours, they have these critical water pumps. They're split case pumps, very common pump, but they're having a lot of sudden rapid failures on the what we call the opposite drive-in pump bearing, and they're down to just one pump right now because the other 2 pumps failed really fast. And so what we're trying to find out, is what is the root cause here? The pumps have always shown these cavitation-like issues or lubrication issues. The bearings are oil lube, and so immediately I'm thinking of are they using the right oil? Another thing that we can look into is there any pipe strain that's causing excessive strain on this bearing specifically? Are they doing a laser shaft alignment, as far as, are they aligning the motor properly to the pump that it could be causing, sudden failures? But these are the questions that we kind of ask. We want to dig into and try to find the root cause anytime that we can.
I've actually got another really good use case on this front with somebody that works on my team, works with a chemical company. And they had this very distinct pattern that was on these pumps where they were trending along just fine, and then they had this rise in their RMS vibration with just some random noise that was present in the acceleration data, random impacting in the time waveform data, and they would go back down, and then they would trend along just fine as if nothing happened. What was actually happening was they were having pretty consistent pump failures, and they were always occurring after these just random rises in vibration. But working with this chemical company, what we actually found out was what their operators were doing in their process was running the pumps dry. Mm-hmm. So it was burning up the seals, and then the next time they would go to run those pumps, they would have a very quick failure because product would flood into the bearing housing on this particular pump design and wash out all the grease very quickly. So there was rapid failures that they were seeing, and it was just due to their process, how the operators were handling it. Nobody educated them on, hey, this type of pump we can't run dry, right, kind of a thing. So again, we'll match the need of what's going on at the facility, because part of what we do when we get installed is we really try to learn the process, learn what the operators do, don't do, what product are you making, how do you make it, what are your current pain points, et cetera, to see where we can help with those current gaps.
Yeah, we've asked that customer that's having these pump failures to add pressure gauges on the suction and discharge piping to see, how that pump's running, because it looks like cavitation, but if we had some pressure readings and had the pump model, we can figure out if they're running, on the curve, off the curve, or how that pump's actually performing.
Another area that we'll integrate is, we're experts in our fields. So whether it be lubrication or vibration, or even some other areas like Chris with RDI, motion amplification. Sites and facilities may not have that type of expertise on their staff. That's not uncommon. For a facility to be able to have somebody dedicated to that type of area is not that common. If you are lucky enough to have that, that's awesome. Definitely take value in those people. They're hard to come by. But we do act as those experts that are that extension of your team. So, and it's, it can even go as far as, even grease. There's been some issues where we've had some customers using grease that was not correct for the bearings they were using. One of those was a high moly grease. You really shouldn't be using moly grease in anything that's an anti-friction roller bearing. So the facility didn't have very experienced maintenance technicians, and for them, grease was grease. Well, that grease gun can do just as much damage as not using that grease gun. So we're also there to, talk with you through those problems to be able to make sure that we are doing the right maintenance practices if the maintenance practice also was causing a problem.
That's great. Thank you, guys. So for motors with high vibration, how effective is adding a little grease in reducing the vibration?
I can take that one. So it just depends on what's causing the vibration. If it's a lubrication issue, yes. So there's a specific pattern that we look for when there is a lubrication issue in the vibration. You get a lot of raised noise floor. We call it hay stacking. Very distinct in the AssetWatch system. So when we see those patterns, what we normally do is notify the customer that it does look like a lubrication issue. We tell them not to over grease, but do everything you can to ensure that you're lubricating it properly. Make sure you're using the right quantity. Make sure it's the right grease. Make sure you're not mixing greases that are not compatible with each other. And then we'll have them, when they do grease the motor, we'll have them notify us where we can view the bearing's response to that grease. There's a lot of times that we see that pattern and we're able to bring that noise level down for a long period of time. And sometimes you'll see it creep back up. We work in conjunction. And I think what we're doing with that is extending the life of the bearing, But if you get to the point where that at that point it's just like friction. If you let that go without lubricating it, it's going to eventually get to the point where your raceways are actually damaged. There's spalling present, something of that nature. At that point, there's lubrication will mask it when you grease it, but it's not going to correct the problem. When your raceways are damaged, it's just a matter of how quickly they deteriorate. And it's when that raceway is damaged, you start seeing the fundamental frequencies of the bearing fault frequencies. So that's one thing we do in the vibration analysis as we're analyzing. We're looking at what specific frequencies in play. So to fully answer your question, if you've got a problem with imbalance where you're seeing high levels of rotational speed, shooting a little grease in it ain't gonna help. But if it's a lubrication problem, it definitely would.
Thanks, Dustin. What are the challenges you guys are seeing when implementing predictive maintenance across multiple sites or different asset types? Dustin, what are you guys seeing?
So the challenge with multiple sites is every facility is different. Everybody's in a different spot in their journey for reliability. You still have some customers that are fighting the battles of reactive maintenance. That sometimes that's a bandwidth thing. They may not have enough personnel to keep up with what all's going on. And then others are fully implementing predictive and precision maintenance practices, vibration analysis, ultrasound, electrical monitoring, doing laser alignments and balancing when they install stuff. So we're mindful of that. When we onboard new customers, we try to get a feel of where they're at with their skill sets. Do you have experienced people that retire? You've got some workforces that are really young and inexperienced. So we're there no matter what the case is. We're there to I think the beauty of our teams, we've got vast experiences and vast backgrounds. So we're there to help walk those younger crews, get really detailed with our recommendations, guide them along and how to check for certain things. And at the same time, we work in conjunction with really skilled reliability engineers and category 3, category 4 vibration analysts on the customer side of things. So we love a situation like that just as well. We collaborate with those guys. So it's all part of the AssetWatch experience. I think that's one thing that we are very mindful of early on is where each customer is at, and we try to help. Not only are we trying to prevent those failures, but we're also trying to coach them along and pass on our experience to them. As far as the different types of machines, we're getting, as our coverage grows, it's getting less of an issue that we're monitoring something that we haven't seen before. We've spread pretty far out. It's growing more and more every day. So it's pretty uncommon now that we see something that we haven't covered before. But in the situation that we do, we've come across something that's new or different. We try to gather as much information as we can, whether it's collaboration with the customer. Maybe they got some pertinent documentation on the machine. A lot of times we'll do research on our own, use the old Google button and see what we can come up with. But one beauty of continuous monitoring is once you gather a certain amount of data, you're collecting day in, day out, several readings, it doesn't take long to get a full picture of all the fluctuations of the process. Your speed changes, your load changes, your different products that you're running. And then you get a good sense of what the baseline is, the highs and the lows. And then if you've actually got a problem developing, those trends are really telling that, hey, something's changing here, something's not right. And that goes back to our AI. Those are the things those changes that AI is looking for, that prioritizing what we're looking at, and then we're getting in and laying human eyes on it and seeing exactly what is going on. What are the frequencies in play here?
That's great. Thanks, Dustin. The next question is, what is your opinion on starting standby equipment just to capture vibration readings? Wait for the next collection cycle or start the standby pump to catch the vibration per the schedule?
Yeah. So, when it comes to online vibration, like if you were to install with an online solution such as what we're doing, that becomes less of a factor to try to accommodate for because of the amount of data that we're going to be taking on machines. And if it's something that was deemed worthy, process critical, get sensors installed on it, we're going to capture those readings when the thing does turn on. If it's just a route collection that's being done currently, and wondering if it should turn the machine on or not, it is best to capture as many machines running as possible, preferably letting it even get up to operating temperature in its process, and not just turning it on for 5 minutes, getting some readings real quick and turning it back off. But to really be running in the environment that it would be typically running in if it was running your process for you. One of the big reasons I would say to promote doing this would be there's certain types of faults that can happen even with machines that are just sitting there. It's not uncommon to obviously have machines that sit on the same skid, pump skids. That's a very common thing. You have a bunch of cooling water pumps that are all sitting on the same skid as each other. maybe a couple of turbo compressors that are sitting really close to each other in proximity, and you can have a condition that's called false Brinelling, where one machine vibrates another. And just the other pump that's not running, it can have an issue with the lubrication plane and the greased bearings being broken, because it's just sitting there being vibrated by the one pump that is running, or machine that is running. And if it's just kind of chattering ever so slightly back and forth, being vibrated by that other machine, you can get to where, because those bearings aren't spinning and circulating the grease within that bearing, that you start to get that metal to metal contact, because it's just sitting there doing this. So the condition is called false Brinelling. It can create bearing defects even though the machine isn't being used. So turning those machines on, running them, taking vibration data can clue you into that, as well as anything else that may have developed while the machine was off. People get crazy with fork trucks sometimes. Things happen on that side of things. So it's good to, as a rule of thumb, to try to catch those things running if possible, and with it being at operating temperature.
Yeah, I have a great example of that. I was working with a contractor at one of my steel facilities last week. Contractor came in to balance a fan, and while I was balancing the fan, he thought, what he did is he did a lift check and found that the clearances on the bearings were bad. I think he found 16 thousandths, and that was way out of spec. So he's like, I'm going to change the bearings. Well, come to find out, the customer, the only bearings that they had in stock were on a spare fan that had been sitting in storage for about a year, really, really dirty environment. And I think forklifts and everything drive through it. So he took the bearings off of that spare fan, installed them on the fan that's in service. As soon as he put it in service, he heard a knocking noise. I invoked readings and looked at the data, and there was an outer race defect on the drive-in fan bearing. So now we're waiting for new bearings to get sent in so they can replace those supposedly new bearings, right away as soon as they come in. I think they're doing that tomorrow.
That's a great example. Perfect timing. Can you guys each talk a little bit about the common faults that you're seeing jump out easily in data and trends?
One thing that I can say that jumps out to me, that the way we've got triaxial sensors at AssetWatch, and they're overlaid. The three axes are overlaid together in our graphs. So when I see one axis separating from the other two in the velocity graph, especially, it takes my mind down that structural issue or resonance path before I ever even go into the data and start looking at dominant frequencies. I'm sure these other guys feel the same way on that one, but there's probably other examples that may come to their minds.
Yeah, I think the majority of problems at the end of the day come down to what's loose, what's misaligned, what's imbalanced, and what bearing's bad. And a lot of times the contributors to those things are your very low-hanging fruit issues. Perhaps it's a wrong grease that was being used, or we just straight edge things, or we didn't know we should check. This skid was brand new from the vendor. We didn't know we needed to check our bolts. They're just very low-hanging fruit stuff that it can be very easily fixed most of the time.
Mm-hmm. I was gonna say, something that really surprised me when I started with AssetWatch is how much I think that we see of over lubrication. But another thing is talking like what Eric said, like just aligning stuff. I've been dealing with a customer that, they kept having the coupling insert wear, shaving showing up, and I see it in the vibration data. The vibration data starts to increase, and it increases pretty rapidly. And I would say, hey, looks like the coupling insert needs to be replaced. But the whole time I'm asking them to have a contractor come in and perform a laser alignment, and I'd like to see the report on the laser alignment. And they're like, well, it looks good, but I'm trying to explain to them that if the coupling element keeps wearing out, the root cause is the alignment. So long story short, they actually finally got a laser alignment done on it, and all the vibration went away, and they haven't replaced a coupling element. So that's my input.
On the lubrication side, some of the big things I look at immediately are viscosity and your cleanliness codes, your ISO codes, your particle counts. Viscosity is going to be the most important aspect of an oil. If you don't have the right viscosity, it's not going to do its job. Trying to pump a gear oil through a hydraulic system doesn't work that well, just like trying to lubricate a gearbox with a hydraulic oil. Conversely, doesn't work that well. So, that's going to be the first thing to really stand out. It also lets us know kind of, did we even sample the right thing? Unfortunately, sometimes things happen. Samples get mislabeled. The gearbox gets labeled hydraulics and vice versa. So looking at that, making sure we can get that corrected if that's the case, or, maybe something else is going on. Maybe that barrel of oil that was delivered was the wrong product. Then on your cleanliness codes, particles in oil do way more damage than people realize. We're looking at a hydraulic system, and you have those particles flying around at high velocity. A lot of these hydraulic systems we're working with now, upwards of 3,500 psi. That oil is moving through those systems whenever it's flowing. Every little particle, every time it has to go around a bend, every time it changes directions in a fitting, whenever it goes into a valve, a cylinder, a motor, every time one of those particles hits the surface, it stands a chance to erode a little bit of it. I've seen this time and time again in different applications where your main relief valves get worn out excessively fast just because we're running our oil too dirty. Whether it be the case that we're just not running the right filters, or maybe we had a filter that had a blow-through incident, so nobody knew how long it was since the last time it was changed, but hey, the differential pressure gauge isn't showing any problem. That can be another thing that happens. So, those particles are hugely important for making sure that we reduce the wear in our components. We're looking at, on a servo valve, 2 micron clearance in a servo valve. Oil needs to be really clean for that. And a gearbox, whenever our gear teeth are coming together, any particle that gets between there just gets pushed into the surfaces. Hopefully that particle's softer than the surface, but that's not always the case. So trying to keep that oil as clean as possible is paramount.
Kyle, is there a table that indicates particle size that each bearing can handle?
There are some various charts out there that kind of relate, particle size to various areas. You can generally look up some things, as far as what the clearances are in things. But generally speaking, the particles we're looking at, you're not going to be able to see them with the naked eye. A good human eye, mine not anymore, but a good human eye can see about 40 microns. And, we're looking at particles with our ISO codes of 4, 6, and 14 microns. So these are all super small, but those small particles do get into those clearances, and that's where it causes the problems. Big particles can't fit, a 20 micron particle isn't going to fit in a 2 micron space. But that 2 micron particle fits in a 3 micron space pretty easily. So, that's the issue.
What's the most surprising insight you found from asset data that a maintenance or reliability professional wouldn't expect?
Honestly, I kind of touched on it a little bit earlier with what I was speaking to with one of the other questions, but just how often it's the low-hanging fruit, easy stuff that'll end up biting you in the butt. Making sure that your stuff is aligned. Are we doing the correct PMs at the right time? Are we over PMing the machine? Putting too much grease, the right grease. Is the process going to invariably create imbalance in this fan? Do we have a PM in place to clean that fan periodically because of that happening? So, at the end of the day, if people can make PM and predictive and precision maintenance programs overly complicated, at the end of the day, sometimes it's easy to go back to the very basics of things here and using your sensory capabilities when you're walking around. That can be something else that helps. Maybe you're out there to do a PM and change a filter on a vacuum pump, as an example. and there's clearly loose bolts that are present there when you walk by and do that filter change. Making sure that your team realizes that, hey, we have these other senses that we can use. You can touch things, you can hear things, see things, smell things that can clue you into issues that are going on that maybe you don't even necessarily need a vibration sensor to tell you what's happening. So bringing it back to basics can go a long way.
That's great. Thanks, Eric. We have time for one last question. What makes the condition monitoring team different here at AssetWatch? Chris, what are your thoughts?
My thoughts is kind of exactly what you said. It's the team of CMEs that we have. We have, 30 analysts, I think now. It's kind of crazy how fast we've grown, but with each one of the CMEs that we bring on board, I think they all have strengths and weaknesses just like everybody else, and their strengths, it's just a very well-versed team. I don't know everything. Eric doesn't know everything. Dustin doesn't know everything. Kyle doesn't know everything. So, when we have questions or we're looking at something and we're not sure about it, we always have the team to fall back on. It works very, very well. Anybody else want to add anything to that?
I think you summed it up good, but that's one thing when I've been here 2.5 years, and that's one thing that really blew me away from the get-go. I think that AssetWatch as a company has done a really good job of vetting people, not only getting the right skill sets, but looking for personality too. There's nobody across the team that has an ego. I mean, we're all come from different backgrounds. We've got different areas of expertise, and because there's no egos, we feel comfortable tapping into each other's experience, and it's instead of one guy's experience, we've got 30 guys' experience, and that's growing all the time. So it's just getting better and better and better.
Yeah, that collaborative effort is really awesome to be a part of. I mean, it's the vibration CMEs are coming over to the lubrication CMEs. Hey, are you guys seeing anything on this? Likewise, we're going over to the vibration guys. Hey, we're seeing this in the oil. Are you picking up anything on the vibration? Yeah. There's just that constant collaborative effort between all of us, and it's truly awesome.
Yeah, I think we also put mechanisms in place to help make sure that the stuff doesn't fall through the cracks, or maybe somebody feels bad about reaching out or whatever. We have all the managers have open office hour meetings with our teams every day, where it's encouraged for team members to come and join. And if there's something that they've got the blinders on, they're looking at an issue and need second opinions, that's a great opportunity that they have to leverage the team and throw the data out there and see collaboratively what are we seeing in that data. So even though anybody can reach out at any time, we also make sure that there's scheduled time for this, so that we're making sure that everybody on the team feels like they're a part of it, and they have the support that they need to succeed with their customers.
Yeah, it really is. And coming from a different department, it's really incredible to see how collaborative you guys are, and how every time you get a new CME, you guys just get stronger. But that's a wrap for today's conversation. I hope everyone enjoyed meeting a part of our CME team. Thank you to Chris, Eric, Dustin, and Kyle for sharing your insights, and to all of our attendees for your thoughtful questions and participation in the chat. We hope that you're leaving with a better understanding of how our team works alongside yours to spot issues early and keep your equipment running strong. If we didn't get to your question today, we'll be in touch with an answer. And if you're curious about how AssetWatch can support your maintenance strategy, we'd be happy to set up a personalized demo. You can get started at assetwatch.com. Thanks again for joining us, and we'll see you next time.
Thank you, everyone.
Thank you.
Have a good rest of the day, everybody.
Take care.